Okay guys, it is time to explore. What we are going to work on is continuing with our earthquakes, but we are going to research a little bit more about earthquakes and structures and how they relate to one another. So what you guys are going to be doing today is we're gonna do a little graphic organizer, just your simple Venn diagram. And we are going to look at the San Francisco earthquake of 1906 versus the San Francisco earthquake of 1989. So you guys are going to take some time and get on your Google Classroom and check out some links that I've put on there, or if you guys want, you can search those on your web browser and I can make sure that they are the correct ones. So we're going to take some time and go ahead and pull those up and do that. And let's see here. While you guys are working on that, I want you to keep in mind some of those vocab words that we talked about in our last lesson. Obviously, we know what earthquakes are at this point. Remind yourselves about how the tectonic plates affect earthquakes, and how aftershocks and tremors tremors being a warning sign, and aftershocks, how they can affect even after the earthquake has finished. And then once we get through this, we're going to share our Venn diagrams over some differences and similarities of the San Francisco earthquakes. And then we are going to be talking about building our own structures. So I want you to be paying attention to the type of materials that were being built with in the first earthquake and how they've improved. We're going to do a little bit of our own research into how today they've improved even further, and types of things that people are using to make buildings and structures more earthquake resistant. Another thing we need to look at is, does location affect the level of damage done to a structure, and is that related to the location over a tectonic plate? And then, how strong are quakes at each level of the Richter scale? So I want you to be thinking, what kind of damage is typically done at that level? What does it feel like at that level compared to higher levels? Alright, so I'll give you guys a couple of minutes to read through those websites and watch the short video. And while you do that, I'm going to be pulling up a video that we can watch together. We won't be watching the whole thing right now, but we'll, get a little snippet of what we should be looking for and things that we should expect when we start to apply our knowledge from the previous unit and this unit, and we are going to be building our own structures. Alright, it's alright if you haven't finished your Venn diagram, and we will share those in a moment, but I would like to go ahead and play a little bit of this for you.
Science Max Experiments at Large. Today, we're going to be looking at earthquakes. Earthquakes! Today, we're going to be looking at how to build something that was supposed to happen earlier. Today, we're going to be looking at how to build something that stands up to the shaking of an earthquake. Earthquakes happen when two plates on the Earth's surface rub together and it causes the ground to shake. Causes the ground to shake. Sometimes it shakes a little, sometimes it shakes a lot. Chances are you do not live in a place that has earthquakes. But if you do, ask an adult what to do during an earthquake so you can be safe. Modern buildings that are built in earthquake zones are designed to withstand the shaking. But how do scientists and engineers build a building that stands up to the shaking of an earthquake? Well, that's what we're going to be looking at today. First thing we have to do is simulate an earthquake. We're going to build a shaker table. And here's what you need. 2 books and... 2 books, 4 elastic bands, and 4 rubber balls. Oh.
We will be doing something similar to this to test our structures on.
Alright, so the first thing you do is actually take your 4 elastic bands and wrap them around your books. Put one set on one side, one set on the other side, till you have that. Then you take your 4 balls and you stick them in between the books, in the middle-ish area. But you don't want to have them too close to the edges. And now 2 at the back, and ta-da! You've made your own shaker table. What are you shaking, you ask? I will show you. You build a tower. Like this one here that I built out of building blocks. So here's what you do.
You'll
need your base to be securely attached to the shaker table. I use painter's tape because it'll come off again without harming the books. And what I want to find out is just how much shaking this tower can take before it falls apart. Ready? And there it goes. And when you've done that, what you do is you be a science maximite and you design another tower. And you tape it down to your shaker table and see if you can make this tower fall down in an earthquake. And if you built it really well, probably won't. But you don't have to just use building blocks. There's all kinds of other materials you can use. Check out this building, which is really tall, and you'll see there's a cup at the top, and that's for a baseball. Put it up at the top, and that means there's a weight up there, and then we shake it, and we see what happens. Oh no! Oh, there it goes. Having a big weight on the top of our tower means we need something that will resist the movement of that weight. So now we're going to start with a triangle. Unlike a rectangle, triangles are very stable. A wider base keeps the structure from swaying too much. And cross braces in the middle mean that there are other triangles within our triangle, all the better to resist movement.
Skip ahead a little bit here.
That happens during an earthquake is soil liquefaction. Liquefaction means something turns to liquid. In this case, the very ground you might be standing on. Here's how you can experiment with soil liquefaction. All you need is a plastic container and some water,
and this
not
will be
very
the final
much,
test
barely
for your
enough
home,
to cover
just
the
for
bottom
fun.
of the container, because what you're going to put in next is sand. And you want to put it in there and spread it around. Just add enough sand so it just starts to turn dry on the very last layer. So, here is a house that I'm going to put on top. And now, I will simulate an earthquake. The water rises up, and it sort of turns to liquid. Soil liquefaction. And heavy things like houses and cars, they tend to sink like that. And then the soil rehardens, and everybody's houses are stuck in the mud.
Being a chef is my absolute passion. And cooking up science recipes is my speciality. I'm Buster Beaker, and this is Cooking with Science.
Oh, hello. And to do that, you need a seismometer. All you need is a ball, some paper cups, some modeling clay, a pencil, your earthquakes that you create on the table.
All right. So, after going over some of that and the things that we've learned through history, I want you guys to start designing a model based on what you've learned. You can do, we've got, let's see, Sorry, the computer is pausing weird. Okay, so after you've done your research, you guys are going to look at future of earthquake-proof buildings. So we're going to pick some materials and some designs, and you guys are going to draw your designs on this sheet here. And then you will approve them with the teacher, myself, and then once that's complete, you guys are going to write a quick little essay, nothing crazy, 1 page that answers the questions about, you know, do you live in an earthquake, or what you've learned about earthquakes, and do you think your current home would survive an earthquake here, and if you would live in the structure that you built, and that sort of thing. So we will get going on this and see where we end up.